All right, after spending some time talking about graphing linear functions, what we're going to do in this unit is look at the opposite of writing linear functions based on certain information. So in this section, we're going to look at writing equations of linear functions in slope-intercept form. So as a quick review of slope-intercept form, again, you're going to be having equations written in the form y equals mx plus b. So the two nuggets of information you are given here is m, which is the slope, and b, which represents the y-intercept. So identifying these things again is a little review, starting with the y-intercept. So the y-intercept represents the value of y when x is equal to 0. So on my graph, that's going to be located here, 0, -2. And again, the y-intercept is also that point where my line crosses the y-axis, which is the vertical axis. And then the slope again is going to be the rise of my line compared to the run, where the rise represents the line going up or down, while the run is going to look at the line moving forward. So from this point, I would go up a certain amount, and I would go right a certain amount. Those two values in this case would be 4 and 4, would mean my slope would go up 4 over 4, which would simplify down to a slope being 1. So our goal in this section is to take information like the slope and the intercept and to write our equation in slope-intercept form. So slope-intercept form again is y equals mx plus b. So the two things that we need to plug in here are m, which represents the slope again, and b, which represents the y-intercept. So let's say, for example, here I give you the slope and the y-intercept straight up. So when I write this equation, slope is m, y-intercept is b. So all I got to do is take those numbers and plug them into their spots. So 3x plus 12. As we do this, notice that I am keeping x and y in my function because every function needs y and x in there in some way because they represent the inputs and outputs of every function. All right, let's say that I have a slope of 0 and a y-intercept of -2. Here I would have y equals 0x and then -2 since it's -2. If I have a slope of 0x means that I'm multiplying it by whatever my input is. Know that anytime it's a 0, I can just drop this term out and I would have y equals -2. Okay, as a line, something that has a slope of 0 and a y-intercept of 2, in this case, would be a horizontal line going through that y value of 2. But again, our goal here is to be able to write the equation here. I give you the information, but we're trying to write it in slope-intercept form. All right, so instead of giving you the information, what if I give you a graph? Can we figure out the slope and the intercept from a graph? So on this first graph, again, the slope is going to be from point to point. It is going to be the rise over the run. All right, so rise over run, we'll start at this first one. I'm going to start at my leftmost point and go to my rightmost point. I'm going to start by doing my rise. In this case, I would go up. Counting the number of boxes, I'm going to go up 6 units, and I'm going to go right 4 units. So my slope then, m, would be 6 over 4. As a fraction, we want to simplify that down to 3 over 2. So in my function, I would have y equals 3 over 2x. And then my y-intercept is the value of y when x equals 0, which is going to be represented by this point here, 0, -3, which means that my y-intercept is going to be the y value of -3. So in my function, I would put -3 at the end. So I've now written my equation in slope-intercept form given this graph. And do the same thing on my next graph. I'm going to start from my leftmost point and my rightmost point. I'm going to go down a certain amount and right. That's going to represent my slope. Because I'm going down 3 boxes in this case, I'm going to label my slope as -3 since it's going down. And then it goes right 4 boxes, so my slope would be -3 over 4, and that cannot be simplified. My y-intercept is going to be my value of y when x equals 0, which again is shown here by this point. It's the point where the line crosses the y-axis. So in this case, my y-intercept b is going to be that y value of 2. Putting these things together, my equation would be -3 over 4x plus 2. Positive 2 because it's above the x-axis. So here I was writing the equation of a line from a graph. All right, last kind of thing is the same, almost the same thing we did before, except I'm not giving you the visual aid. So now we have to write the equation given 2 points. So again, we're looking for the slope and the y-intercept here in order to write my equation. The slope is going to be the rise over run between the 2 points. Now, how do I figure out the rise and the run based on the points? Well, the rise again, so if I think about the rise is looking at the change in the y values, so y2 and y1. The run is looking at the x values and how they change, so x2 and x1. So in my points, if I have my x1 and y1 and my x2 and y2, in order to find the rise, I'm going to take my y2, which is my -1, and subtract the y1, which is 5. Do the same thing for the x's. On my x2 is 0, my x1 is -3, so 0 minus -3. And combining those, that's going to give me my slope. So -1 minus 5 would give me -6. 0 minus -3 would give me a +3 because I'm subtracting a negative, which is going to simplify down to -2. So I can find the slope by just looking at the values in my points. And then I got to remember that my y-intercept, now that we don't have a graph, this one's going to be a little bit harder to view. But my y-intercept is always a value of y when x is 0. So if I look at my points, notice here I am given a point of 0, -1. That point right there is my y-intercept. That fits this of 0, -1. That is a value of y when x is 0. So therefore, my b value would be -1. So putting these together, my equation would be -2x minus 1 with my slope and my y-intercept plugged in. Similar example here. To find my slope, again, I'm going to look at my x values. So I have x1 and y1. I have x2, y2. So to find the rise, I'm going to subtract the y values. So -5 minus -5. And then I'm going to subtract my x values. So 8 minus 0, x2 minus x1. Simplifying the top, -5 minus 5, or sorry, -5 minus -5 is going to give me 0. 8 minus 0 is 8. And then if I divide those two out, that's going to simplify down to 0. All right, so that means that this is going to be it's going to have a slope of 0, which I talked about before was a horizontal line. Then my y-intercept, again, is always going to be a point of 0, y. So if I look at my points, you'll recognize again that I have a point given to you of 0, -5. So that means my y-intercept would be at the value of -5. So my equation can be written as 0x minus 5. Now the 0x, again, that can cancel out, so it's just going to simplify down to -5, which in this case, again, would be a horizontal line going through -5 on my graph. And notice that if you look at my two values, 0, -5, 8, -5, notice the y value doesn't change. It doesn't rise or it doesn't go down at all. There is no rise at all because it stays the same. All right, next example, we'll do the same thing. Only difference here now is we're written in function notation. Oh my Lord, have mercy on my sweet baby soul. So function notation is the whole y equals f of x business. Okay? When you see this, what you have to remember is that the number inside the parentheses, f of x, that number is describing the input. And the input is always your x value. And the number on the outside, well, that's my y value or my output. So when I look here at the first problem, f of 0 equals 10, think of this as like having a point of 0, 10. 0 is my x, 10 is my y. Same thing in function notation. Here I would have 6, 34. That's an ugly looking 6. So it's just written differently, but it's the same thing we did in the previous example. You're still given an x and a y here, and you're still given an x and a y here. So the first thing I want to do is find my slope by doing 34 minus 10. And then I'm going to do 6 minus 0 for my x's. That's going to give me 24 divided by 6, which is a slope of 4. And then I having to identify my y-intercept. Again, the y-intercept is going to be that value of y when x is 0. So in this case, if I recognize my points, I have f of 0 equals 10 is the same thing as saying 0, 10. So I should recognize that that is my y-intercept. So I know I have a y-intercept of 10. And finally, putting that together, I would get 4x plus 10 as my linear function. All right, kind of went through a whole bunch of examples, so what I want you to do is try this next one on your own. I have f of 2 equals 6, f of 0 equals 2, so what would I get for my linear function for here, for 2 points written in function notation? Alrighty, so you should have the 2 points of 2, 6 and 0, 2. It's finding the slope by using the rise and run again. I'm changing my y values over my change in x. I get -4 over -2, simplifies down to 2. My y-intercept, I get, again, my value of y when x is 0. So I would recognize a point 0, 2, which means my y-intercept is also 2. So plugging those in, I get 2x plus 2 as my function. All right, now let's apply this to a modeling problem. So here we have, it says, excluding hydropower U.S. power plants and use renewable energy sources to generate 105 million megawatt hours of electricity in 2007. And by 2012, the amount of electricity increased to 219 million megawatt hours. Here it wants to write a linear model. Ooh, fancy words. Linear model that represents the number of megawatt hours generated by these energy sources as a function of the number of years since 2007. What the heck is that even saying? Okay, and then it says to use this model to predict the number of megawatt hours in 2017. So here's what you got to think about. You're given some information at the beginning that in 2007, that the number of megawatt hours used was 105 million. So what I want you to think about is think about this as a point. 2007 is the year that we're starting at. That's kind of where our information begins. So think of this as like year 0. I'm going to write this as a point. Think of this as a year 0. We were using 105 million megawatts. Or megawatt hours, I should say. Now, instead of writing 105 million, I'm just going to look at the 105. Then we are given in the year 2012, we used 219 million megawatt hours. Now, 2012 is 5 years later, so think of that as year 5, and I'm at 219. Now, think about this for a second. Ooh, I have 2 points, x1, y1, x2, y2. So I can take these 2 points and figure out my slope and my y-intercept. To find the slope, I'm going to take 219 minus 105, which are my y values, and my x values would be 5 minus 0. And what I'm going to do is try and simplify those out. And I get 114 over 5. That means 114 megawatt hours or million megawatt hours in 5 years, and that's how much it's gained. And then I want to find my y-intercept, and again, my y-intercept is going to be my value of y when x is 0. So if I consider the points that I wrote, that would be the very first point in 2007. There was 105 million megawatt hours. So that means my y-intercept would be 105. So my function here I can rewrite as 114 over 5x plus 105. This is explaining the rate of change, how much megawatt hours of electricity I gained in 5 years. And this represents the number of megawatt hours we started with when we were collecting this data. So this would be my function or my model that we're writing. Now it wants to know to predict the use in 2017. So 2017, here's what we got to think about. Based on 2007, how many years later would we be in 2017? And know that this would be in year 10. So my question is that in year 10, what would be the number of million megawatt hours of electricity we would generate? So what I'm going to do is I'm going to take this 10, that's my x value, and I'm going to plug this in to figure out my y value. So using my model, I'm going to do 114 over 5 times 10 years, plus that 105, which represents the original amount in 2007. And now all I have to do is simplify this out. And in the end, you should get y equals 333. So that is 333 million megawatt hours of electricity that would be generated in 2017 based on this model. And this is kind of why we write these linear models so that we can use them to make predictions or estimations based on things we see in real life. Guys, got any questions on writing these equations in slope-intercept form? Make sure you jot them down, bring them to class. We'll see you next time.